we'll see how to use a single Linux machine and create a routing space for us so that we can ping between domains and verify. So for that, the basic requirement is you need a Linux machine. You can either take a VM or normal Linux machine, and then you have to install VPP. So to install VPP and to install the Linux in virtual machine, there are different videos which I have already done. In case you are not aware, you can check that. So now I'll explain the setup how to make, and then we'll start doing it. Actually, what we are going to do is we are going to take a Linux machine, and we are going to create a namespace. Two different namespace I am going to create, VPP1 and VPP2. So this is the first step. We'll start with that. So this is VPP. I don't have any interfaces, and this Linux machine if config. You see, as you see in the previous video, we have 3, 8, 9, and 10. So now NetNS. This is the namespace. So we don't have any namespace. So as per this diagram, we wanted to create VPP1 and VPP2. So IP NetNS add VPP1 and VPP2. So now we have created two namespaces, VPP1 and VPP2. The next step is we have to create this line is there, right? This line is nothing but a tunnel. So that is VEth tunnel. So one end will be inside the namespace, other end will be in the VPP. Mainly it will be inside a Linux machine, and we will move that Linux machine inside VPP. Now we'll see this step. So for creating that, we have a command called as IP link. So using this, here you can see once we create it, we can see this here IP link name. This is the command IP link name. We are going to give the VEth1. This interface will be inside VPP, and type. What is the type? This is a VEth type, and peer name is VPP. So as per this diagram, so like this VEth, we are going to create inside the namespace, and outside will be VPP. I will move that inside the VPP. That's why it is host VPP. You will understand. So with this, now if I see IP link, VPP1 will be created. VPP1, one end is VPP1 and the other end is VEth VPP1. So similarly, we will create the second interface. Going to be VPP2. So that's all. Now we have created the second link. So as per this diagram, so we have created this interface, but we have not moved it inside VPP. So now we will see how to move it inside VPP. Come here. We don't have interface, so we have to create a host interface. So create host interface name VPP1. VPP1 is nothing but this one. So this one. So actually see, it has created a four bi-directional VPP1 to VPP like that. So now I am creating VPP1. So this has created host VPP1. This one. So now VPP1 and host VPP1 are back to back connected. Whatever you put in here, you can get it. So same way we can create host. So now this is the interface which VPP will understand. So for this, you have a, if you come here and see, this VPP1 is moved inside that. This VPP2 is inside the second namespace. So, sorry, it's not namespace, inside VPP. So now we'll go inside the namespace and we'll check. Exec VPP1 if config IP. So now you have to set the names, move it inside namespace. So for that, what we should do, we should make the device up and then add it inside the namespace. So initially, if you see inside VPP1, we don't have anything. So what are the steps is set dev VPP1, same VPP2, you should make it up. This one. Once we made it up, we have to move that inside VPP. For example, if you see here, it will be here only. V is VPP1. So this we are going to move inside the namespace. So for that, this is the command. Link set V1. We are moving inside namespace VPP1. The same way for 2, we are moving inside VPP2. Now IPNetNS exec VPP1 if config. We got that interface. Similarly, V2 will have V2. So this is how we have configured this. So now we will have yellow, right? We can make it yellow also up. So that when we give if config, we can see both the interfaces. So now as per this diagram, we have created namespace VPP1, we have created namespace VPP2, and we have created a tunnel interface with one end as VPP1 and other end as host VPP1. And this similarly in the other namespace. So now we'll assign an IP. Vector VPP1, VPP2. Now set interface state sorry and interface name interface should be up. Show interface address. So we have not configured address, so we'll configure set interface IP address. So this is the command. Interface name host VPP1 and then address. So for VPP1, we are going to give 10.10.1. There it will be 2 host, in VPP it will be 1. So 10.10.10.1/20. Similarly, in host VPP2, we are going to have 1. So now all the VPPs will have .1 just for easy to remember it easily. So we have two things 10.1 and 10.2. So these are the two interfaces in VPP. Now we will create the same in Linux. It is just easy VPP1. So for VPP1 we have decided 10.10.10.1 /24. Similarly, we can do for V2. Sorry, it should be 2 as per this diagram because 1 is for VPP, 2 is for namespace. So if we give this, we have this address. Now for VPP2, it will be 20. 20.20.20.2/24. So now we have made this setup. Right? We have made the setup. So now we'll give ping and sec. And before that, we can see the IPR. So this is the R. In namespace also, you can see the R-N. Initially, we don't have anything in VPP1 as well as in VPP2. So from VPP1, VPP1 is 10 network, right? So we will ping to 10.1. 2 is the self. First we'll do the self and check. Self ping is working. So meanwhile, here also we have a command called as show trace. We can trace the packets. So trace add AF packet input 100. So this is the command to add the trace commands. So we'll see whether if any packet comes in VPP, it will be shown here. So this I'm putting, it will come to the VPP. So you can see 10.1 ARP is getting sent and ask ICMP packet echo request. You can see the flow ARP rewrite. So sending the packet outside ICMP. ICMP echo request and reply. So all these are the packet flows. So once this is done, see it takes host VPP output. So this is how, because VPP1 only we are sending. Because it's VPP1. In case I give 20's IP, it will not go. It will say route is not done. So similarly, VPP2 is nothing but 20, right? So 20 is network. You can just confirm it. It is 20. This 20.2. So we will ping to 20.20.20.2 is self. 20.1 is to the VPP. So now here you should be able to see the VPP2 trace. It's the old one. Recent should be VPP2. We can just do the clear also and check. So this is VPP2. So now we are able to reach from VPP1 to VPP1, VPP2 to VPP2, but not from VPP1 to VPP1. From this 10.2 to 10.1 we are able to ping. 20.2 to 20.1 we are able to ping. Now we have to ping from 10.1 to 2. So for that, what we miss is just is a normal IP route. IP netns VPP1 IP route. So we don't have a route. Similarly, for 20 also we don't have a route. So we'll start adding IP route. Add. We need 20.1, right? So to reach to 20.20.20.0/24 via 10.10.10.1 VPP's IP. You can just check in VPP1. Route will be added. Similarly, we'll add for VPP2 also. VPP2 IP route add. So we already have 20 in VPP2. So we have to add for 10. 10.0/24 via, it should be 20.20.1. So now we have routes from both sides. Here we can do clear trace, and again if we see show trace, nothing will be there. Now we'll add a trace. Now from VPP1 20.20.20.2 2 is this the next namespace. From VPP1 to VPP2 going to ping. Sorry, ping is missing. You can see the flow. So it takes what is the software interface. So not this. This is the ICMP echo request, echo reply. So it goes from 10.2 to 20.2. So what MAC it, so from VPP1 it goes to VPP2 and it has to come, reply has to come to VPP1. So this is how, so this is the full flow. How the packet goes. So we can just now confirm whether the IP is learned properly. Sorry, MAC is learned properly. Or -a. Initially we had nothing. Now this is the IP. So we'll confirm which IP it has taken. So this IP is 89. So it didn't learn the host IP. It has to learn the VPP's MAC only. It didn't learn it should not learn this. So we'll see whether it has learned correctly. Show interface. Show hardware interface So host VPP1 is 02302FE and ends with C334. So we can see the C334. Other one is 60, ends with 6059. So 6059. So host VPP2 SMAC is learnt in namespace VPP2. In namespace VPP1, it has learned the host VPP SMAC. So this is how it has learned. You can in VPP you can see the IPFIP. This is the IPFIP table. You can directly give a particular IP also and check 20.20.20.2. So for 20.2, it goes to host VPP2. So if we take 10.10.2, it should take the VPP1. So like this you can verify. So this is how you can connect between two namespaces using two different routing domains and using a basic routing protocol. Sorry, not protocol, basic routing with a static route using a Linux machine and a host VPP. Thank you.